Okay, we are looking at the back side of Unit 8, Day 2, Proving Quadrilaterals or Proving Polygons. In this section, it says, given the vertices of a quadrilateral, determine the quadrilateral's most specific classification: parallelogram, rectangle, rhombus, or square. Justify your answer by using distance and slope formulas. Show your work. So the big key here is there's a lot of work to show because they want the distance formula and the slope formulas. If you're comfortable graphing on the coordinate plane and you want to graph these and then show your work on here, that is fine. You can also just do what we did on the last example and just make sure that when you are drawing this, remember we don't know the exact shape, so you just know that in a picture that R, S, T, U, that these letters go around. So if this picture, if opposite sides would be parallel, then we would be talking about RS and UT. So when you're doing this, I'm going to start with figuring out the distance of each of the sides. So I'm just going to label like side RS. And then I'm going to use the distance formula in those 2 points to figure out distance. So the length of RS, 5 minus 1 squared, and 2 minus 3 squared. If you want to enter all that in your calculator, this comes out to 4 squared is 16. Negative 1 squared is 1. So RS is the square root of 17. And you can get decimals on these, that's fine. I'm going to leave it that way and I'll just show you why you don't have to go that next step. So next side I would see is ST. So I'd look up here at the ordered pairs for S and T and find the length of those. So 4 would be my X, 4 minus 5 squared. And then my Y is negative 2 minus 1, 2 squared. That's negative 1, which is 1. This comes out to negative 4 squared would be 16. So this one is also square root of 17. And I'm going to keep going around the whole four-sided figure like this. So the next one I did RS, ST, now I'm going to do TU, or UT. Do minus a negative 2, you're going to end up with plus 2. So again, this comes out to 4 squared is 16, or negative 4 squared. This is 1 squared is 1, so you get square root of 17. And the last one side we'd have to do is RU, just to prove that they all came out to the same. RU is the first and the last here, so 0 minus 1. And negative 1 minus 3. That's negative 1 squared is 1. Negative 4 squared is 16. So all four sides came out to square root of 17. So there's two objects out of our choices that have all four sides congruent. Our choice now, is it going to be a rhombus or square? Because in both of those cases, all four sides are congruent. So now we have to check to see if the slopes are perpendicular. If the slopes are perpendicular, then we know it's a square, because that means they're 90 degrees. If the slopes are not perpendicular, or opposite reciprocals, then it is a rhombus. So let's go ahead and figure out the slope of RS, and we're going to compare that to the slope of ST. Those would be consecutive sides. Is this side perpendicular to that side? So you use the slope formula to figure that out. So on top, RS would be Y minus Y, so 3 minus 2, or 2 minus 3, whichever way you want to do that, and 1 minus 5, or 5 minus 1. So this comes out to 1 over negative 4. So now I want to find the slope of ST. On top you subtract your Y's, so that would be negative 2 minus 2. And on bottom you get 4 minus 5. So that gives me negative 4 over negative 1, and two negatives make a positive. So 4 is the slope. If you look at RS and ST, these slopes are opposite reciprocals. So the opposite of negative is positive, and the opposite of reciprocal of 1/4 is 4 over 1. So these would be perpendicular lines. If those lines are perpendicular and all four sides are congruent, then my answer will be square. It's a lot of work to show, but we're basically doing the process of proving that the sides are congruent or not, and proving if the slopes are perpendicular or not. I'm going to have you guys try the next one. We'll draw our picture. I would pause the video at this time and try it on your own and see if you can figure out what kind of shape this is. So I'm going to go ahead and start my side AB and find the distance or length of that side. 1 minus negative 2 is plus 2. 4 minus 3 squared. So we have that 3 squared is 9, 1 squared is 1. So this is square root of 10. And we'll do the next side. And you can show as much or little of work of the distance formula as you need, as long as you have the setup and your answer. And you can write these in decimal form as well. It's just easier to see if they're all the same, but just leaving them square roots. BC, the distance would be 1 minus 1 squared plus 2 minus 4 squared. This is 0 squared plus negative 2 squared, which is 4, equals square root of 4. So you can leave it square root of 4, or the square root of 4 is just 2. Next side I have is C and D. Negative 3 squared is 9. Negative 1 squared is 1. So you add those, you get square root of 10. And the last side I need to prove is AD. The length of AD would be negative 2 minus negative 2 makes a plus. And 1 minus 3. So you get 0 squared plus negative 2 squared, which is 4. 0 plus 4 is square root of 4, 2. So if you look at this, we don't have all four sides congruent this time. Since all four sides are not congruent, we have the option, if we know opposite sides are congruent, it's either going to be a rectangle or parallelogram. Those are our choices if not all the sides are congruent, but opposite sides are congruent. So the difference is, in a rectangle, we have to have perpendicular lines. So to check that, we're going to find the slope of, let's say, AB and BC. And we're going to check those slopes to see if they are perpendicular or not, like we did on the last one. So the slope of AB, you subtract your y's over your x's. We get 1 over 3. On the BC, subtracting the y's, we get 2 minus 4 over 1 minus 1. 2 minus 4 is negative 2, 1 minus 1 is 0. So these are clearly not reciprocals of each other, which means they are not perpendicular. If they are not perpendicular, then this has to be a parallelogram. So I'm just going to write slopes not perpendicular. If they are not perpendicular, it can't be a rectangle. So my answer was parallelogram. Alright, the last examples we have is, they're going to tell you the shape it is this time. Using our properties, we're going to try and find the missing point. So to start with, go ahead and graph these. First one, J is at 2, 1. Go over 2, up 1. K is at 4, 0. So that's J. This is K. And L is at 6, 4. Okay, so something that we know, based on that picture, we want to figure out where would point M go. Remember J, K, L. So I know point M has to go in this area. So the thing that we know about a rectangle, opposite sides are congruent, but we also know that slopes are perpendicular. So if you look at this, the slope of this line is down 1 over 2. Or you can say the slope of KL is up 1, 2, 3, 4 over 2. So if I do that same slope, and I count the same slope from J, I should be able to find M. So up 1, 2, 3, 4 over 2. So that should make this look like a rectangle. So M, counting from here, if I go up 4 over 2, the new point for M is 4. So M is 4, 5. So you use your slopes in order to figure that out. In a parallelogram here, let's graph these points. A is at negative 5, negative 1. B is at negative 4, 2. We have A, we have B, and C is at negative 3, 0. So, following these lines, C has to be in this area over here. We know that AB and CD should have the same slopes. So 1, 2, 3 over 1. The slope of 3 over 1 was AB, and that should be the same slope we get for the other one. So let's go up 3, 2, 3 over 1. And that should make a parallelogram. So this point here should be point C. Its ordered pair is 1, 2, 1, 2, 3. So C is at negative 2, 3. So you're going to graph those and find the missing point.